All right, guys, we're going to take a look quickly at how to solve some of the basics of this mobile stuff. I'm not going to do the entire mobile just for the sake of time, plus don't have that much room on the board. But first thing you want to do when you're making a mobile, if you're making one in class, is to sketch out where everything's going to go. I've got objects A, B, C, D, E, F, and G. I've got at least 3 tiers: top tier, second tier, tier hanging beneath that. So I know this one would be good to go if this is one that I was going to be making in class. Folks at home, you guys have a worksheet to do in terms of like all virtual people. Yours is already drawn for you, and you just have to figure out, well, how do I set up the equations for this? For both the worksheet and if you're building one in class, first thing you need to do is make sure you know the masses of absolutely everything that you can know the masses for. Again, folks at home, sometimes you're solving for the distance and sometimes you're solving for the mass. It depends on your particular situation, but the setup is exactly the same. For you folks that are actually building a mobile, for the most part, you tend to know all of your masses. I wrote those down. So object A is 13, B is 19, C is 32, and so on. So you want to get a list of all your masses if you're actually physically building this mobile, so you have an idea what everything is when you're going to be putting it up there. If you have objects where the masses can vary, you can change the masses in some way. That's okay too. The setup will be the same. It's just which one is the variable is the thing that will change. So you always want to start from the bottom and work your way up. So I could start at either 1 and go up, or I could start at 3 and go up. But you can't do 1 if it's got stuff that you don't know beneath it. The reason I recommend doing it from the bottom up is that you don't necessarily, if you're building one in real life, what if I want to change one of these objects and I've already measured the top tier? I got to redo the top tier. So it's easier if you just start from the bottom, work your way up. So I have labeled them. This I'm calling tier or rod 1, 2, 3, 4, 5. That's the order I would solve them in. You could do these 2 first, then these 2, and then jump up. It doesn't really matter. You just have to start sort of at the bottom of either side, work your way up. So I've drawn tier 1. This is with A and B here. I've drawn it a little bit bigger. I put in the numbers where I could put in the numbers. Again, if you're building one of these, you have to decide everything but one item, one thing. Basically where that thing is going to be located. That's the biggest thing that you need to do is figure where is everything except for one item. So you need to know how long is the rod. I said this one is 8 inches. FYI, just to keep the numbers easy for this example, I'm going to say the rod mass is 1 gram per inch. So that means the total rod is 8 grams because 1 gram per inch, 8 inches is 8 grams. So I know that object A, which has a mass of 13 grams, is 3 inches away from the string that's holding this up. That's the pivot point. That's the balance point on this seesaw, this rod here. I know the center of the rod has got to be at the 4-inch mark. So if the string is 3 in from the edge, the center is 1 more inch over to put it at the 4-inch mark. And the question is, well, where do I have to put object B to get this thing to balance? So here's what we're going to be doing. We're going to be setting up our equation and we're balancing torque. All the torques or forces on this side I have to balance with all the torques on the right side of my string. So remember, torque is the force times how far away it is from the string. Now the force is going to be the weight, the mass times 9.8, but since force of gravity for A and B in the rod all have 9.8, you can simplify and cancel all the 9.8s out, so you can really just use the mass if you'd like. So for A, I'm going to have on my left side of the equation that mass, which is 13 grams, times 3 inches. I have nothing else here on the left side. I get to my string that's holding it up. So that's my equal side. Now I've got the rod, which as we said, the rod's going to have 1 gram per inch. It's a total of 8 inches. So that means it's 8 grams. And how far away is it from the string? 1 inch. And that's going to be plus object B, which is 19 grams. I would have measured that. So 19 grams times, that's my question mark, I'll call that an X, you can call it question mark, whatever you want. That's the thing I'm solving for, is where does object B have to go to get this to balance? If you just pick a number for there, then you don't have any unknowns, and you better be a really good guesser in order to get this thing to balance, because it's probably not going to. So from here, I'd be able to grab a calculator, and I'd say, okay, I have to do a little algebra maybe. I would be able to move the 8 over, so 13 times 3 is going to be 39. I subtract the 8 over, so now I've got 31 on the left side, and then I divide by 19. You want to see that done. My left side here is 39. gram inches. Since gram inches is a little bit onerous to write, I'm just going to stick with the numbers from here on out because you kind of need to know how to do this. And, video can only be so long. On the right side, 8 times 1 is just 8 plus 19x. I'm going to subtract the 8 over. So 39 minus 8 is 31 equals 19x. Now I can divide by 19. And what that gives me is, that one I don't know off the top of my head, 31 divided by 19 gets me 1.63. So 1.63 inches. So that means that for B, needs to actually be moved in quite a bit and only be 1.5 inches away from the string. So I'm going to have a lot of rod over here. That's okay. If that's the way you want it to look, you can have it look that way. So sometimes the way you sketch it is not going to be to scale. So I found out object B has to be 1.6 inches away from the string. That's what my question mark is. Okay, so now I would move up to 2. Well, 2 has really 3 objects here. It's got C, it's got D, and this string has all of this, A, B, and the rod hanging from it. Well, if I add up A, it's 13, and B is 19. So that gets me 32, plus the rod was 8. So 32 plus 8 gives me a grand total of 40 grams. That's why this string is as if it's just got one object that's 40 grams. You have to worry about, do I have to do anything with it? No. That whole tier can be summed up as one object that's 40 grams. So I got 40 grams here. C is 32 grams. D, that's going to be 15 grams. The rod, 12 inches, 1 gram per inch. It's going to be 12 total grams. So I'm going to do my equation now. Everything on the left, torque-wise, equals everything on the right. So I'm going to have 40 times, this says it's 5.5 inches away from the string because I'm putting the string at the 5.5 inch mark, meaning the center of the rod is only 1/2 inch away from the string. So 40 times 5.5 plus C is the thing we're going to try to find. When you have 3 objects, I find it kind of easier to have the middle object be the thing that we're trying to find. So object C had a mass of 32 when I look at my list, times, I'll call that X, thing I'm trying to find. I get to my big string here. So now over here, the rod, which had a mass of 12, times 1/2 inch away, plus D, which was 15, times, that's 6.5 inches away from the string. So if you want to simplify this up, we can. 40 times 5.5 is 220. Plus 32 times X. I can't simplify that yet because I don't know what X is. That's going to equal 12 times 1/2, which is 6, plus 15 times 6.5, which is 97.5. So I just multiplied everything that I could. Now I'm still trying to solve for X, so what I'm going to do is I'm going to move that 220 over to the left. So that leaves me with 32X equals 6 plus 97.5 minus 220. FYI, that right side of 6 plus 97.5 minus 220 gets me negative 116.5. So I get 32, forgot the 2, 32x equals negative 116.5 divided by 32. And I get negative 3.6. Negative? How did I get a negative? That means that this was 40, and over here was only 15. Meaning that I can't put the 2 really heavy things over here is not going to balance. So the negative just means, on my sketch, I guessed wrong. I thought it would go on the left. That means it needs to go on the other side. So it's the other side, 3.6. So C needs to be to the right, 3.6 inches. That's where I would put it on here when I'm making my mobile. People at home, if you're full virtual and you're doing the worksheet, you're not going to get a negative. I didn't set it up so that you would get a negative. But if you were actually working on this in real life and you're building one, the negative would just mean you guessed the wrong way. It's got to go on the other side. All right, we couldn't do 5 yet because we haven't done 3 or 4. I'm just going to do 3 because 4 is 2 objects, 5 is like 2 objects. So it's going to be very, very similar in the setup and just for the sake of time. So for 3, I've got object E and object F. E is the one I'm trying to find where it's going to be located. The F is going to go 5 inches away. The total rod is 10 inches. So again, I picked where the string's going to go. I picked where F is going to be. I know where the rod center is because it's always going to be at the center where that weight is. So what that leaves us with is E, which has a mass of 34 when I look at my list. 34 times X, or my question mark. I have nothing else on this left side. So I say equals, now my 2 torques on my right side, which is the rod mass, 1 gram per inch, and it's 10 inches. Multiply, I get 10. So 10 grams times 2, because it's 2 inches away, plus the mass of F, which is 14, times that is 5 inches away. So 34x equals 10 times 2 is 20. 14 times 5 is 70. So 34x equals 90. Divide by 34. Divide by 34. Calculator. 90 divided by 34. And I get 2.6. So x equals 2.6 inches. So I would know where do I have to place E? I've got 3 inches to put it in. I need it to be 2.6 inches away from the string, or from building this at home, 0.4 inches away from the edge, however you would want to measure that. Now again, when you folks are doing this, if you're actually building a mobile, you can do this in inches, or you can do it in centimeters. I recommend just staying consistent with that. But this is generally how this is done. You're just balancing torque. So you take the left side of the string, all the masses times their distances away from the string equals the right side masses and distances. That's how that works. And when you build up, like we did here, this can be thought of as just one object hanging. And that one object has the mass of everything that's hanging from that string. So the mass of A, the mass of B, and the rod added up. So that's how to do a mobile in a nutshell. If you have any questions, please reach out. Just let me know. I'm always here to help. Best of luck.